We've spent the last few minutes understanding Coulomb's law. Now it's time to use it. Imagine these two charged particles are placed 2 meters apart. We know the value of each charge. Can we calculate the force between them? Absolutely. Let's solve it step by step. The first step is always the same. Write down the given information. Notice that the charges are given in microcoulombs. Since the SI unit of charge is the coulomb, we convert microcoulombs into coulombs. Remember, 1 microcoulomb equals 10 to the power minus 6 coulomb. The second step is to write the formula. Then substitute the known values carefully. Take your time. Most mistakes happen because students rush this step. Now simplify the numbers first. Then simplify the powers of 10. Finally divide by the square of the distance. The force comes out to be 0.0135 newtons. The answer isn't just a number. It tells us something about nature. Since both charges are positive, the force is repulsive. Each charge pushes the other away with this amount of force. We have learned how to calculate the force between charges. But here is another interesting question. Will this force always remain the same? Or does the surrounding medium also matter? Like if we put the charges in water, will it affect the final answer? We'll answer that in the next segment. Thank you for watching.